Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ala Natasha binti Ashrul, student ID 2020-824978. I studied Diploma in Actuarial Science at UiTM Cawangan Negeri 9 Campus Seremban 3. My course code is CS112 and my course group is CS1121F.
Hi and Assalamualaikum. My name is Nur Ala Natasha binti Mat183. My student ID is 2020845898. I'm from CS1121F. Course name Actuarial Science and program code Mat183.
Hi, my name is Nuha Irdina binti Iskandar Zuhairi, ID student 2020895452 from Group F, Actuarial Science, subject Mat183.
What is differentiation? Differentiation in calculus could be a process of finding the derivative or rate of change of a function. It contrasts to abstract nature of the theory behind it. The practical technique of differentiation can be carried out by purely algebraic manipulation using three basic derivatives, four rules of operation, and a knowledge of how to manipulate functions. What is related rates? In calculus, sometimes we need to find the rate of change of one quantity related to other quantity. The rate of change is usually with respect to time. For the example, rate of change of y is equal to dy over dt, and the rate of change of x is equal to dx over dt. If the rate of change of quantity is positive, thus the quantity increases with respect to time. If the rate of change of quantity is negative, then the quantity decreases with respect to time. For example, dy over dt is equal to 0.5 cm per second and dx over dt is equal to negative meter per hour. Therefore, y increases at the rate of 0.5 cm per second and x decreases at the rate of 3 meter per hour. 5 steps for solving the related rates problem. Step 1. Determine the rate of change that is known and determine the rate of change that need to be found. Step 2. Construct formula or equation that relates variable in step 1 and draw appropriate label, figure, and illustrate the variables in step 1. Step 3. Differentiate implicitly both sides of the equation with respect to time. Step 4. Substitute the known rate of change in differentiable equation in step 3. And step 5. Solve for remaining rate of change.
The problem that we have is about a container that has the shape of a right circular cone. As shown in the figure above, the height of the container is 10 cm and the opening diameter of the container is also 10 cm. Water in the container is evaporating so that its depth, h, is changing at a constant rate at -3/10 cm per hour. For problem A, we need to find the volume V of the water in the container when h is equal to 5 cm. For question B, we need to find the rate of change of volume in the container with respect to time when h is equals to 5 cm. In this question, it is stated that a container has the shape of an open right circular cone. As shown in the figure above, the height of the container is 10 cm and the diameter of the opening is 10 cm. Water in the container is evaporating so that its depth h is changing at a constant rate -3/10 cm per hour. This is the dH over dt. As we can see, it is negative. When it is a negative number, it means that it is decreasing. Next, we need to solve question A. Find the volume V of water in the container when H is equal to 5 cm. Now, this is the figure. As we can see, the opening of the diameter is 10 cm and the height is also 10 cm. In the question, it gave us the value of H, which is 5. Now, to find the volume, we need to find R. To find R, we need to do a ratio. R is equals to H over 2. This is because D is equals to 10 and height is also equals to 10. Next, we know that formula to find the volume is 1 over 3 pi R squared H. Substitute R into the formula. We get 1 over 3 pi H over 2 squared H. Solve it and we get H squared over 4 times H. Next, we simplified 1 over 3 pi H cubed over 4. This is not the final answer. What we need to do next is to insert the value of H into the formula. In the question, it states that H is equals to 5 cm. So now we need to insert 5 into H. So 1 over 3 pi 5 cubed over 4. Use a calculator. 5 cubed over 4. We get 125 over 4. So it is equals to 1 over 3 pi 125 over 4. This is also not the final answer. 1 over 3 times answer. We will get 125 over 12 over 12 pi. So this is the value. This is the volume. Don't forget to put the units cm cube as it is a volume.
For this question, we need to determine the value of dV over dt when the H given is 5 cm. Based on the question, we know that the diameter of the opening is 10 cm and the height of the container is 10 cm. So both of them are the same. So we also know the value of the H over dt is negative 3 over 10 cm per hour. The first step is we need to express R in terms of H. So we got the R is 1 over 2 H. So we use the formula of volume cone, which is 1 over 3 pi R squared H. So we substitute all the information given and get the value of V, which is 1 over 12 pi H cubed. The next step is we need to differentiate the value of V to get the value of dV over dH. So we differentiate all of this to get the answer, which is 1 over 4 pi H squared dH over dt. By using this formula, we can substitute all the informations that we got to get the value of dV over dt when the H is 5 cm. So as the conclusions, the answer is negative 15 over 8 pi centimeter cube per hour.
In the conclusion, we can conclude that related rates can be applied in many situations. Second, the solution that we use to find the answer for this related rates question are succeed. Last but not least, the formula and the step in this problem solving are available to use. That's all from us. Thanks for watching.